Hello, let me go over the solution for test number two. Uh, the first problem, we have the ANOVA table as following. We have four groups, adult, subject, um, and we have control using drug A and drug B and drug C. The higher score means patients were more depressed. So the outcome was depression, and this is the ANOVA table. And I ask you to answer following question. Do these data provide sufficient evidence to indicate the difference in the mean heart rate among these four type of subject? That alpha 0.05. So you're going to set up your hypothesis, which is a null is you have four group, mu of depression for group 1 equal 2, 3, and 4. At least one mean are different. Then you have to find critical value because our numerator degree freedom is 3 and our error degree 56. 3 and 56.95 would be 2.76. I used 3 and 60 because I did not have 56 in my F table. So you can round it close to the value you have. And since 7.47, your F test is greater than 2.76, we reject the null and conclude that these one mean of depression are different. Now, using Tukey multiple comparison output, which group are different? So you have the Tukey uh, outcome, and I ask you to look at that Tukey outcome and see which one is different from the Tukey outcome. So that's the outcome we have here. If you look at the Tukey outcome, we see control. There is no connection A letter with control and other drugs. That means control is different from group A, drug A, B, C. And also there is no connect the letter drug A and B, C. So that means drug A different from B and C. However, B and C are the same. So control is different from A, B, and C. Drug A is different from B. Drug A is different from C. All of the above is correct answer for this problem. So uh, that's the D was correct answer. Question two, we have a survey was conducted for 58 patients in one clinic. The following is part of the output. We would like to examine the relation of social support by race, group, and sex. So again, here we have factorial design. We have three groups, and we have our outcome here. So if you look at the overall model, is significant. So and social support is your outcome. So the question is, what is overall F test is 3.04, and that's the correct answer. What effect are significant, the main and interaction, that alpha 0.05. Again, you're going to look at type 3 sum square, and so you see here, again, the group is different, and the race is different. So, and if you look at these main effect and the interaction, you would see there is no three-way or two-way interaction significant. So if you look at both factor, group, and race is the significant one. So that's the correct answer. The following is the output on age, tribe, glycerin and weight for the subject, and we have the correlation matrix. Again, what is the sample Pearson correlation for age and triglyceride? Here is age, and again, Y is your triglyceride. So that is your correct answer. That's 0.85. What is the sample experiment correlation for weight and triglyceride? This is weight, this is triglyceride. So this is the correct answer for part B. What is the conclusion to test if for weight, age, and weight? So if you look at age and weight, you see the since the p-value is less than alpha, therefore you reject the null, and there is a linear positive relationship between age and weight. That's the correct answer. Question 4, again, we have simple and multiple regression on age, triglyceride, and weight, and our outcome is triglyceride here. So the question I asked based on the output fit the triglyceride predicted by age. So you look in the simple regression, so model. So you have to find the model triglyceride and age. It's so predicted by age. So age was our x variable. So you find the model with x. So that was weight. This is the so the first model is age. So this is your intercept. This is your slope. So you would write the equation as triglyceride equal negative 1.06 plus 1.77 age. So it was positive, the intercept. And fit the model triglyceride as age and weight. So you add weight also. That's the prediction for that. Test your slope is significant for model 2 weight as independent variable on triglyceride. So the weight we wanted to see if significant. If you look at the p-value here, again, is less than alpha, therefore is significant. So that is the correct answer. What is R and for model 3, the R and R square? Again, these are R and R square for the adjusted 0.78 for both of them. What would you be? It would be triglyceride someone who is 42 years old and weight 132. Again, you're using the prediction equation. You replace the age 42 and weight 132 and simplify, you get 51.43. That's the correct answer. A random sample of 100 cases of heart attack and control were selected. Each subject was asked whether or not they were taking aspirin pill 80 milligram every day before the heart attack. The following table information we have for a heart attack and aspirin pill. So this is the chi-square. What is the expected value for cell 2 and 3? This is cell 2. That's the expected value. Again, and cell 3, 55. You can see it tells you the first one is frequency, the second value is expected value, and then percentage, cell percentage, row percentage, and column percentage. What is the chi-square value? Again, the chi-square value is 18.18. Can we conclude that case and control differ with respect with taking aspirin? Again, since the p-value 0.0001 is less than alpha 0.05, therefore we reject the null and conclude the case and control different with respect to taking aspirin. That is the correct answer. Question 6. Let's say there is a total of 500,000 live births in California for 1 year. Let's say total population of as July 1st was 38 million. Also, the number of women between age 15 to 50 was 10 million. So use the data to calculate what is the crude birth rate. Again, crude birth rate is total number of birds during year, total population as July times K per thousand. So 500,000 divided by 38 million times 10,000 would be uh, 131.58. General fertility rate is based on uh, so based on uh, total number of live birth during a year, total number of women, childbearing age times K would be 500. The following table is the information of 1,000 subjects regarding heart disease and secondhand smoking. What is the relative risk? Again, using the formula for relative risk, probability disease given factor over probability disease over non-factor, 50 over 350, and 10 over 650. 9.29 is the correct answer. What does relative risk mean? Relative risk means the correct answer, if those are exposed to secondhand smoking, are 9.29 times more likely to develop heart disease as compared to those who do not expose to secondhand smoking. What is the odds ratio? So you can use two different formula, probability formula. Again, probability disease given factor over 1 minus probability disease over factor divided by probability disease over non-factor over 1 minus probability disease on non-factor. So 0.143 over 1 minus 0.143 divided by 0.154 over 1 minus 0.154, which gives you 10.70. Or you can use AD over BC, which is 50 times 640 over 300 times 10 with 10.67. And what does that mean? The odds of developing heart disease is 10.65 times higher for those exposed to secondhand smoking compared to those who do not expose to secondhand smoking. Again, the difference between relative risk and odds ratio is relative risk, you go from risk to condition or disease. Odds ratio, you go from disease or condition to the risk factor. Question 8, I asked, we have a random sample of 12 HIV patients. In one clinic was given quality life instrument. A researcher does know the distribution of quality life. She wanted to test if the average of quality of life different from the standard score, which is 30. Do you use parametric tests or non-parametric tests? So yes, because sample size is small, we use non-parametric tests. What statistical test would you use? You would use sign rank tests because it's one sample. Let's say she now have divided her sample to group of 6 subjects and wanted to examine difference of quality life between two groups. What statistical test would you use? So Wilcoxon sign rank test would be the correct. Let's say wanted to examine the difference of quality life for 3 groups of 4. What is statistical?